Okay, so what we're going to do in this section is we're going to talk about exponential growth and decay. And we're going to look for, in this video, we're going to look for a multiplier. So what's the actual, kind of if you want to look at it, rate that it's increasing at. I don't want to call it a slope because it's not a constant rate. It's going to change as for example, time progresses. And we're going to go ahead and evaluate exponential expressions to model some sort of growth and decay. So some later videos we're going to do some application problems. Next slide, we're going to talk about what model best fits this. It's not linear. We do kind of have a slope. We do have an intercept, and as I stated in the previous slide, the slope is not constant as we move from x value to x value. It is not quadratic also, and so this is what our exponential functions are going to look like. And so as we look at this, I'm going to graph it real quick. You can graph this on your calculator, and you would just put your exponent as the variable x. It's t here, so maybe this is some function related to time. But if I was to graph this, and we can think about, well, what's our y-intercept? Our y-intercept is going to be when t is equal to 0, right? Because, or x, because our intercept is when the independent variable is 0. So what's y equal to 25 times 2 to the 0? Well, the y-intercept would be 25. I know the general shape of the graph, and you get comfortable with it. This is one of those basic functions that we talk about. And so somewhere at 25, it's going to cross the x-axis, or excuse me, the y-axis. And now if we put a value in, for example, 1, so if I put in 1, I'm going to get y is equal to 50. So I know at 1, I'm going to be all the way up to 50. So this guy's going to grow really, really fast. If I put in negative numbers, what we know about negative numbers is we know that it's going to cause the graph, or excuse me, the number to flip, or the reciprocal. So if I put in negative 1, so what happens on the other side of this y-axis? Well, I know that this is going to flip, so I really have 25 over 2, which is 12.5. So I know at negative 1, I'm going to be at 12.5. So this is kind of the shape that my graph is taking, and it's got this upward trend from left to right. What's actually going to happen is I'm going to get this graph that's going to slowly start to increase, and then all of a sudden it's going to shoot up as these t values, or x, so this is the same as x, increases. This graph, the way it's set up right now, we can manipulate it a little bit, but notice it is not going to cross the x-axis. There's no way that we're going to get 0 out of this. Y will never equal 0. So in some equations, if I complete some sort of transformation, I would have it cross the x-axis, but without any type of transformation to shift this guy down, I will never cross the x-axis. And so that's what our exponential function looks like, the exponential function. So we have a couple different pieces. We have what's called the multiplier, which is 2. Okay? And so that's something that we're going to have to look at, because that's what we're going to look at for whether it's growth or decay. A is like our initial value. And sometimes the multiplier is called b. And then this is our exponent. And so these are the different pieces of our exponential equation. So let's talk about the multiplier real quick. And this will be, so we have two types of multiplier. We have growth and we have decay. So if it's going to be growth, that means we're going to be increasing by more than of our current population, or whatever it may be, the money that we're investing. So if I have 12% growth, okay, what I do is I take the 100% and I add 12 to it, and so I have 112%. So if my initial population was 1, I'm increasing by 112%. Well, what we need to make sure when we multiply percentages is that we convert it to a decimal. And so that's going to give us our new population. And then I would just multiply those two guys together. And this is very, very basic, so I'd be 1.12. If I don't include the 100%, I don't have the growth added on to the existing population. Okay? So then to deal with decay, I just subtract. So I take my percentages, I subtract them, I'd get 93%, and when I actually compute, I'm going to use the decimal to compute this. And these are how we identify multipliers. Now, multipliers are going to be given to you in a word problem. We'll see a couple examples with those. You need to actually be able to pick out the multiplier.